Hi everybody, have a great day to all. In this today's session, we will discuss about the aromatic compound. First, we will see the criteria for the aromaticity, but before that, we will see the basic things like what is element and what is a compound. Element means it will contain a one kind of atom like O2, H2. It will having one kind of atom means that will known as a element. If it is compound means it will have two or more kind of atoms like H2O and NH3. These are the compounds. In a compounds we will have two type of compounds will be there, and one is the aromatic and another one is the aliphatic compounds. In this section we will see the aromatic compounds, so that we will see the aliphatic compounds here. Aliphatic compounds, basically we have three type of compounds. One is the alkane, alkene, and the final one is the alkyne. Here a compound which one has having C single bond, C means that compound will be a alkane, and which one is having a double bond means that is alkene, and triple bond will present here means that is alkyne. It will see some simple examples for this alkane, alkene and alkyne. The chemical valence of carbon is 4. So 4 bond will be there. It will fill for hydrogen. This structure is known as the alkane. In this structure we will reduce the one hydrogen here, and this type of bond it will show alkene, and one more we will reduce the hydrogen here, and this bond it will shows alkene bonds. So that's all about the aliphatic compounds. So here we will see the aromatic compounds. Aromatic means a pleasant smell, that is the aroma. So if a compound will be aromatic mean it will have some certain rules and criteria will be there. Here four major criteria will be there for aromatic compounds. First thing is it will be a cyclic and planar structure. Then the second thing is it will have a sp2 hybridization, and it will have a delocalization of pi electrons. And the third thing is it must be a stable one. And the final thing is it will obey the Huckel's rule. What is the Huckel's rules? Huckel's rule means a 4n plus 2 rule and 4n rule. A compound it will obey a 4n plus 2 rule means that compound will be a aromatic compound. If a compound it will obey a 4n rule means that compounds will be a anti-aromatic compound. That will discuss deeply in the next slide. And these are all the criteria for the aromaticity. Let us see the aromatic compounds. In aromatic compounds, the first rule is the acyclic structure. The first rule is acyclic structure. And the second thing is Each atom will be a sp2 hybridization. First we know about what is the hybridization. Here three types of bond will be there. The first one is sp3 hybridization, second thing is sp2 hybridization, and the final thing is sp hybridization. Here we have sp2 hybridization there. So the first rule is a cyclic structure. And the second thing is sp2 hybridization. Each atom is having sp2 hybridization. That means alternative single and double bonds. Likewise, delocalization of pi orbitals. That means the bond is shift here. Automatically this bond will be shift here. Finally, this bond will be shift here. It will shows this type of delocalization. So that is the third rule. And the fourth is a stable compound. This compound is a stable one. And the final one is it will obey the Huckel's rule. Which compound is obey the 4n plus 2 rule means that compound will be a aromatic compound. And which one is obey the 4n rule means that is the anti-aromatic compounds. Here it will obey the 4n plus 2 rule. I will explain that. 4n plus 2 rule, we have substitute 1. We substitute n as 1 here. We will get a 6 pi electrons. Here we will see the examples also. Aromatic compound, benzene is the best example for the aromatic compound. Here it is a cyclic compound and is a stable one, and it will have a sp2 hybridization and delocalization of pi electrons here, and it will obey the Huckel's rule. That is the main thing, isn't it? Here each bond is counted as 2 pi electrons. We will get the answer that 6 pi electrons in the Huckel's rule. Here we have counted 2, 4, 6. So benzene is having a 6 pi electrons on the structure. So absolutely benzene is a aromatic compound. Let us see the anti-aromatic compounds. In anti-aromatic compounds, likewise the same rule, a cyclic structure and sp2 hybridization and delocalization of pi electrons. But here two things will be changed. One is a compound will be unstable, and the other one is a compound it must obey 4n rule. Okay, here we will substitute n as 1 here. We will get 4 pi electrons. Let us see the example for the anti-aromatic. Cyclobutadiene is the example for the anti-aromatic. That will count the pi electrons here. 2, 4. We have 2 double bonds here. So a counter electron will be 4 pi electrons, and we get the answer in the rule of 4 pi electron. So cyclobutadiene is a anti-aromatic compound. We will see the next one, that is non-aromatic compounds. It will fail any one of the 4 criteria. Compound will be a cyclic or not, it will stable or unstable, it will obey the 4n plus 2 rule, or it will obey the 4n rule, and it must be having pi electrons. Likewise, one important thing is it will having sp2 hybridization, as well as it will having some sp3 hybridization also. Okay, that is the main thing for this non-aromatic compounds. Here we will see the example. Cyclooctatraene is an example for non-aromatic compounds. Likewise, we have to see some other examples for the further clarifications. Here's some other examples. The first one is the non-aromatic compounds. A second thing is an anti-aromatic and is an aromatic. Only it will change a one rule. It will obey for a 4n rule. That's why it is a anti-aromatic. It will obey a 4n plus 2 rule. That's why it is a aromatic compounds. Likewise, these two compounds and this compounds also. Here, lastly, I will show that sp3 hybridization, isn't it? This non-aromatic compound, it will have sp3 hybridization here and sp2 hybridization here. That's why this compound will be a non-aromatic compound. That's all about this section. Thanks for watching this.